A scriptable object is a data container that saves large amount of data independent of class instances. And scriptable object can reduce your project memory usage by avoiding copies of values. I have this augmented reality currency scanner project, and this project have an implementation of scriptable objects. Opening the documentation of this project to see the project details to better understand the utilization of scriptable objects. And these are the major points in this project. At point number 5, it uses scriptable objects to create a data container that holds the image info and will be linked to XR reference image library. Actually, let's have a demo of this project to better understand it, and then we will discuss how this project is utilizing the scriptable objects.
Canada, $20. China, 20 yuan. America, $20. Canada, $20.
Using this app, you will be able to detect banknotes, and on detection, it will speak out the banknote name. After developing this app, expanding is very easy. After completing this project, we can add multiple new country currencies without writing a single line of code. We will be just updating the image reference library and data containers with the new currency images. And now let's discuss how the scriptable object work. In the project, open the script folder and open currency scriptable object. A currency scriptable object class is inherited from scriptable object, and each of its instances contain currency value, currency name, currency type. So this data remains constant over the course of gameplay, making it specially suitable for storage inside a scriptable object. And this line number 4 create a menu, and we will click on it to create a data container. It will create a data container to store the currency information, and that file name will be currency data container. At line number 7, we are creating a list of currency data class. And at line number 10, we are defining a currency data class, and which have a currency and a binding. And in the binding, we have a country name and currency type. It will be more clear to you when you will see a data container in the Unity editor. In Unity, click on Assets, open Create, and here we have currency data container. It will create a new currency container data. Select it to view what we have in it in the inspector panel, and that's a list of currency data class that we have defined. Let's add one to add a new element. And here we have all the fields that we have defined in the script. So this container will help to hold the non-changeable values. In the currency value, we are adding a USA 500 when a user will detect a $500 banknote, and then some other script in this project will send a string to match with this string. Once the currency value is matched, that means we have the data of that note, and then that script will grab the data from the binding, country name, and the country type, and then utilize the information accordingly, as we have seen in the demo, adding one more entry for the $100 bill. And that's how it's easy to extend the data. Similar to this, we can have a multiple data containers that can hold information of each country to make it a more simple. Like this data container is to hold the information of Canada. This data container is for China. We have a very less information in these data containers because it's just a simple demo, and we don't need to add these data containers in the scene view to any game object. The data is saved to scriptable object is written to the disk as an asset, so it can be persisted between sessions. And this is the currency image library. It's basically a XR reference image library. In this library, we have added all the banknote images to detect. In the currency value, we have given the same currency value in the data containers and in the image reference library. And whenever we match a banknote from this library, we send a request to a script which have all the data containers attached. You see this currency scanner script, it have all the country currencies, and we have a list of all the data containers. If that value matches from the data container, we grab the data and show to the user. And by using the scriptable object, it's very easy to extend this app. To add more currencies, we don't need to write any code. We just need to add a new data in currency image library and in the new data container. Further, I'm showing you the currency scanner script. But you don't need to really understand this completely. So I will just give you a quick high-level overview that is more relevant to the scriptable object side. Here we are using an AR foundation and AR subsystem. And the required component is AR track image manager. It's used for detecting images in AR. We are getting AR track image manager and assigning it to m_track image manager. In all country currency, we assign all the data containers. It's a list. All this part is for tracking in AR. And on track image change give us few events when it detects images, and we update few visuals accordingly. The update info is just for the experimental testing for now. It's not much optimized at the moment. It's getting the tracked image data and matching with the data containers, and also updating the few visuals on the screen. And this last method is for formatting strings. As a conclusion of this video, save memory and stay organized with ScriptableObjects. Set static data and settings in assets in the project just once, even if you have a lot of game objects. Even if you add 1,000th instance of a prefab to your scene, they still refer to the same data stored on your asset. Setting up the set of values just once guaranteed consistency. As your game scale up with more unit types, simply create more scriptable object assets, and you can maintain your gameplay data just by tweaking the centrally stored assets. Scriptable objects don't replace keeping persistent data for rest of your application saves file, where the data may changes during gameplay. It's a workflow suited more for your sorting your static gameplay settings and values. Unlike parsing a data from JSON or XML, reading a scriptable object asset won't generate garbage, and it's a bonus, it's faster. Optimization tip for the scriptable object. I recommend binary serialization formats such as message pack or a protocol buffer for safe data, rather than the text-based one such as JSON or XML. In the project reviews, these binary serialization formats reduce the memory and performance issues. And you can read more about scriptable object from the Unity documentation. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next.